abundant metal in the Earth's crust, where it is found in the form of hydrated oxide like bauxite. Important ores of aluminium are bauxite. The chemical formula is Al2O3 2H2O. Bauxite is the principal ore of aluminium. Bauxite is chemically known as hydrated aluminium oxide. Corundum. Chemical formula is Al2O3. Corundum is the aluminium oxide. Cryolite. Chemical formula is Na3Alf6. Cryolite is sodium aluminium fluoride. The extraction of aluminium from bauxite involves 3 steps. First, the purification of bauxite using Bayes process. The second, the electrolytic reduction of anhydrous Al2O3 by Hall and Herold's process. And the last step is the purification of impure aluminium by Hope's process. Bayes process. In Bayes process, impure bauxite is converted into pure alumina. The conversion process involves mainly 3 reactions. Concentrated sodium hydroxide solution is heated with amphoteric bauxite at a temperature of 150 to 200 degrees Celsius under pressure to get sodium aluminate. Sodium aluminate is then diluted with water at a temperature of 50 to 60 degrees Celsius. Thus, sodium aluminate gets hydrolyzed to form solid aluminum hydroxide and sodium hydroxide. Finally, dried aluminum hydroxide precipitate is ignited at a temperature of 1100 degrees Celsius to remove water molecules to get alumina. Bauxite is also concentrated through Hall's process, in which sodium aluminate is prepared by adding sodium carbonate to bauxite. When excess carbon dioxide is passed through sodium aluminate in the presence of water, it forms aluminum hydroxide along with sodium carbonate. When dried aluminum hydroxide is ignited, alumina is formed. Alumina is a very stable oxide, and aluminium shows a strong affinity to combine with oxygen. Therefore, reducing it with reducing agents is practically difficult. Hence, it is reduced by electrolytic reduction through Hall's Herold's process. In this process, alumina is heated with cryolite and fluorspar in an iron tank with a lining of carbon inside. Once the oxide melts, a carbon rod fixed with a copper clamp, which acts as an anode, is introduced into it. The carbon lining of the container behaves as a cathode. When current is passed, the metallic aluminium is liberated at the cathode and oxygen at the anode. The aluminium so formed is collected at the bottom of the tank in molten stage, and it is taken out through a small outlet. The molten aluminium obtained after electrolysis is more than 99% pure and is refined further by Hope's process to make it 99.9% pure. In Hope's process, electropositive aluminium is refined in a tank with 3 immiscible layers. The upper layer is pure molten aluminium with a carbon electrode immersed into it, which functions as the cathode. The middle layer is an electrolyte, which is a mixture of cryolite, barium fluoride, aluminium fluoride, and calcium fluoride. The bottom layer is a impure aluminium. The tank has a lining of carbon which acts as an anode. When current is passed, aluminium ions from the electrolyte move towards the cathode, where they gain electrons to form pure aluminium. More aluminium ions from the impure aluminium in the bottom layer enter the middle layer to get electrons and get collected at the cathode. The bottom layer is replenished with impure aluminium at frequent intervals. Impure aluminium is refined by Hope's process to produce 99.9% pure aluminium. Aluminium is used in manufacturing of automobile components, construction processes, manufacture of electrical wires, packaging medicines and pharmaceutical products, manufacturing of soft drink cans and espresso coffee makers, and manufacturing of utensils.